Dear students, welcome to all. Now we will discuss the concept of range of space wave propagation or line of sight distance. This is the topic related to the space wave propagation. So for this, first we will see what is LOS. LOS means line of sight. So first we will see the definition. Line of sight distance is the distance in which both transmitting and receiving antennas are usually see each other. Okay. If you see here, this is the transmitting antenna, this is the receiving antenna, and this is the earth surface. Okay. This line is the earth surface. Uh, on the earth surface both the antennas must see each other, means the communication is possible if the both antennas are aligned in the straight line. Okay, then only the communication is possible. That is the definition of the LOS. Then it depends on height of transmitting antenna. Okay, this line of sight is depending on the height of the transmitting antenna HT or height of the receiving antenna HR or effective earth radius factor. This is the earth surface now. This is the effective earth radius factor, which is denoted as K. Okay, for standard atmosphere K is given as 4 by 3. The formula for K is R dash by R, where R dash is the effective radius of Earth and R is the actual radius of Earth. If you want to get the effective radius, if you add actual radius plus extension radius, then you will be getting the effective radius of the Earth, which is denoted as R dash. Now substitute the K value in this equation. K is known as 4 by 3 is equal to R dash by R. From this, you can calculate the effective radius of Earth. R dash is equal to 4 by 3 into actual radius of the Earth. The final equation of the LOS is the distance or range of the line of sight is given as square root of 17 of square root of HT plus square root of HR in kilometers. Now we will be going to prove this equation how it came. Okay. For this, you need to go to the diagram here. This is the figure of optical range of LOS propagation. Here see, this is the earth surface. Okay, from the middle of the earth surface you take one point with a distance r, that is called as O. Okay, you consider the middle point with a distance r. At some distance you place the point O. The distance from O to transmitting antenna is r, and the distance from O to center of the earth is r, and the distance from O to receiving antenna is r. Okay, this is the distance. Distance is nothing but r, here we denoted. So here what the d1 means, d1 is the range of the transmitting antenna or distance of the transmitting antenna. D2 is related to the distance or range of the receiving antenna. Okay, if you want total distance, you can simply add d1 plus d2. You will be getting the total distance. Okay, so d1 is the distance of the transmitting antenna, d2 is the distance or range of the receiving antenna. If you want the total distance between the transmitting and receiving antenna, you need to add d1 plus d2. Okay, so these are the terms which we denoted in the diagram. Now we will go to the proof how this root 17 of HT plus HR came. Now we will be going to discuss here. For this, you consider for the range calculation from delta AB naught. Okay, for this you can take this triangle. Okay, you can take this triangle delta AB naught from AB naught. Consider this triangle. Okay, consider this triangle. So what the Pythagoras theorem is telling, a square plus b square is equal to c square. Yes, so sum of squares what, d1 square plus r1 r square is equal to, here the height of the antenna. Okay, height of the antenna is the HT here, and plus r, the distance from transmitting antenna to O is r. So d1 square plus r square is equal to ht plus r whole square. So now expand this equation. By expanding this equation, here d1 square plus r square is equal to, this is a plus b whole square. So a square plus b square plus 2ab, that is ht square plus r square plus 2htr. So here r square and r square get cancelled. Then the equation becomes d1 square is equal to ht square plus 2htr. But we can neglect the ht square. Why? Because here ht square is far less than 2htr. Okay. So by neglecting this term, the above equation becomes d1 square is equal to 2rht. Okay. From this we can write the range of the transmitting antenna d1 is equal to square root of 2rht. Okay. Means the range of the transmitting antenna we have finded now. Okay. D1 is equal to square root of 2rht. Let it be the equation 1. Now similarly, you consider this triangle. Okay. Triangle cbo, this is the triangle. Now consider this triangle like this. Okay. By considering this triangle, you will be getting the equation d2 is equal to square root of 2r into hr. Okay. Already in the equation 1 we have done d1 is equal to square root of 2r ht. In the same manner, d2 is equal to, we will be getting the 2r into hr. Okay. Now total line of sight distance d is equal to d1 plus d2. In order to find the total distance, if you add the equation 1 and 2, we will be getting the total line distance. Okay. So d is equal to d1 plus d2. Let it be the equation 3. Now substitute equation 1 and 2 in equation 3. What the equation 1 here, d1 is equal to square root of 2rht plus d2 is the square root of 2rhr in meters. Now separate the square root of 2r, then the equation becomes square root of 2r of square root of ht plus square root of hr in meters. Let it be the equation 4. But r is the radius of the earth. Okay. It is given as, given as 6370 kilometers. This can be rewrite as 6.37 into 10 power 6 meters. Okay. Now substitute this in the r value. Okay. Then the equation 4 becomes 2 into 6.37 into 10 power 6 of square root of ht plus square root of hr in meters. Therefore if you solving this, you will be getting the range of entire line of sight or distance of the entire line of sight, that is 3.57 of square root of ht plus square root of hr in kilometers. This is the concept of the line of sight distance.